Hello my dear learners, welcome back. So today in this video, we would be doing the last problem of exercise 5.1 NCERT complex numbers of class 11. Okay, so the question is already put up on the board. So this question we have to convert it in the form of A plus IB. So like I have told you all in my previous videos, whenever a question on complex number is written, always denote it as Z and then only proceed with the later steps. So I can write this as Z is equal to so and so. Now I'll start simplifying the problem. So this can be written as numerator resembles A plus B into A minus B. So A plus B into A minus B is equal to A square minus B square. So using this identity, I will simplify the numerator. So I can write this as A square minus I root 5 the whole square divided by, in the denominator I have root 3 plus root 2I minus root 3 minus root 2I. So since I have a minus sign in the denominator, I can expand the binomial using this sign. So this can be, the denominator can be written as root 3 plus root 2I minus root 3, minus into minus becomes plus root 2I. So here plus root 3 minus root 3 will get cancelled, okay, in the denominator. So likewise in the next step when I simplify, I get this as 9 minus. So please pay attention my dear learners. So root 5 into root 5, please bear in mind it is always equal to 5. Similarly, if I have root 3 into root 3, it is nothing but 3. Root 3 into root 3 is nothing but root 3 the whole square. Okay. So when I have to write it, when I expand it, when I have two root symbols of the same number, so I will get back the countable number. I will get back by same real number. Okay. After removing the square root. So I get this as 3. So denominator I have 3 square which is equal to 9 minus square root of 5 the whole square will give me 5 into I square divided by, see, in the denominator I have root 2I plus root 2I. Root 2I plus root 2I. Now what will be the answer for this particular expression here? See, for example, if I have 2 plus 2, I will write this as 4. Correct, no? So in the place of x, if I have it as, for example, x plus x. Okay. So can I write this as 1 time x plus 1 time x giving me 2x? Correct, no? Similarly, if I have a plus a. So 1 time a plus 1 time a will be equal to 2a. Likewise, using the same logic, if I conclude, if I compare it with this particular expression here, what will be my answer? I have 1 times root 2I plus 1 time root 2I will be equal to 2 times root 2I. I hope this concept is very clear. I have just explained you again with some more examples if you want. I will just give you an example here. See, for example, if I have y plus y, 1 time y plus 1 time y will be equal to 2 times y. Okay, since I have a plus sign, it is getting added. Similarly, if I have x square plus x square, 1 time x square plus 1 time x square is equal to 2 times x square. I hope with few more examples you have understood the concept of how to add like terms. Okay, so when I add like terms, what is the value or what is the final answer that I get? Okay, so in the denominator I get this as 2 root 2I. And we all know I square is equal to minus 1. Let's substitute. I get this as 9 minus of minus 1 divided by 2 root 2I. Okay. So this can be further simplified as, and just erase these steps which are previously done. So this can be written as 9 minus of minus will become plus. So 9 plus 5 will become 14 divided by 2 root 2I. Now one more very important concept, my dear learners. We all know that in the denominator, if I have a root symbol, I have to rationalize. Okay? Or in complex numbers, for example, if I see an I term in the denominator, I have to get rid of that I. Or otherwise, in a layman's language, if I see a root symbol in the denominator, I have to get rid of it. Now, I have a root symbol and I also have an I. So what should I do? I have to get rid of both. So what will I do? I will rationalize the denominator with the opposite of whatever sign it has. So here it has plus of 2 root 2I. Correct, no? But before that, do you see this particular term 14 divided by 2 root 2I? See, 14 divided by 2 root 2I, here 2 is getting multiplied with root 2I. So in that case, to just ease my problem with one more step, can I cancel out these two values? So this, when I cancel, I get it as 7 divided by square root of 2I. So I think, yeah, we could have even rationalized with the previous step. But yeah, since the terms are getting cancelled, obviously we can ease our problem, cancel out the step and then proceed it further. So now if I rationalize, what will I get? I will have to rationalize root 2I. So I will rationalize the denominator with the opposite sign. So here I have plus root 2I. So I will multiply this as minus root 2I divided by minus root 2I. So this can be written as minus 7 root 2I divided by, plus into minus will be minus root 2 into root 2. I have already told you, when roots get multiplied twice, you will get back a countable number, which is nothing but whatever is there under root, you will get that as your final answer. Okay, under root, whatever value, that answer itself. So I get this as root 2 into root 2 will be equal to 2. I into I will be equal to I square. So this can be further written as, please do not cancel out the minus terms because I have I square here. After you substitute all the values, then only whatever cancelling, whatever is there, that you do. Okay, otherwise, until and unless you substitute everything, please do not cancel out the terms or the signs. So I get this as 7 root 2I divided by minus 2 into minus 1, because we know I square is minus 1. So I get this as minus 7 root 2I divided by 2. Now this is going to be my final answer. Correct? This particular final answer has only it does not have a real term, it has only an imaginary term. So obviously, when I write any complex number in the form of a plus ib, it should have both real term and imaginary term. Since I have only an imaginary term here, I will write this as 0 plus minus of 7 root 2I divided by 2, where a value is equal to 0 and b value is equal to minus 7 root 2 divided by 2. Hope you people have understood. I have explained each and every step in detail. If you have any problem or any difficulty in any step, please stop the video then and there. Resume the video from wherever you find it difficult and then only proceed. Please, my dear learners, make sure that each and every step is understood and each and every concept is strong. Please make sure that you are making all your concepts strong, because we know that concept is our strength. If concept is not strong, then I'm telling you, my dear learners, anything in mathematics to build from the basics becomes very difficult. So therefore, with this note, I'll come up with much more videos to make your difficulties easier. Please stay tuned. Now for this video, I'm signing off. Thank you all.